Record. Okay. Let me. Hang on with me, please. Where are we? Okay. Oh, come on. Let me double check the first example. Sorry, this is not the first example. This is our. Yeah. I think this is the first example of the class. Okay. Is auto rotate. हाँ हो गया. Okay, so this is screen. This is again you have to bear with me. In fact, let me pause the recording. Why our students have to. Okay. Hello, everyone. I hope everyone is doing all right. So the question says that we have an object which is like a wheel and it has a radius of 0.4 meter in this fellow, and the radius is 0.75 meter, the outside. The question says that if a horizontal load is being applied, T plus 10s bracket n is newtons, s is seconds, mass is 100 kilograms, you have to find omega 2 after 5 seconds. T is time. T is the time after 5 seconds. So eventually when you go through the steps, you have to figure out this after 5 seconds. Okay. I think the only confusion I will have to explain is the friction direction, which I think I will skip at this moment because you have to find out the direction going through some steps. And at this point, we have to go with an intuitive feel. I will just go over it that we are considering the friction in the left and I will have you solve the problem. So other than that, if this is the problem, you can do this by different ways. You can do it by Newton's law, for example. But right now, the method I will follow is, again, you can disagree with me if you want, but the method I would love to perform is using this one. That is integral 0 to 5 summation m. Then I will have dt, if you remember. You remember integral f dt is equal to a change of momentum. So integral summation m dt is equal to change of momentum. So mass multiplied by velocity is the momentum. So I will have Ig multiplied by delta omega. I use the.
You said we can find Newton's laws as well.
Yeah.
So how would that be? Summation of forces in the
summation of moments about the center of mass. Do it yourself. I'm not gonna do it. If you remember last time I solved one problem with this and then one problem by summation of forces by Newton's law. Summation of moments about center of mass is equal to Ig multiplied by alpha. I'm not gonna do it because this is our topic and I will stick to it here. So it is equal, we can do it, Hussain, by the way. So it is equal to, now just finish the question by writing what is my free body diagram. I think all of you can see the free body diagram that I made. Again, the friction is the point of contention for us. I will try to find some, let's say, video or file which can help us in determining the direction of the friction. But again, this is not something that is our focus, that in different directions of rolling, what will be the direction of friction. I have to just consider an intuitive direction and I'm considering as left. So on this note, let us proceed. So I will have integral 0 to 5. What is the summation of moment? Now you tell me the real stuff.
What times 0.4?
Yeah, right. So it will be P times 0.4 is what our student told us. So I will just follow his advice.
Friction force was towards the right.
That's what I'm trying to tell you. I'm considering it towards left because for different cases the direction is different. As this point, I'm just saying that, let's say intuitively, I know that the friction is towards the left and I'm just going with this problem. I understand your concern.
Previously, we all said it was towards the right.
Yeah, it's not always actually. It depends on case to case, and we are not getting into how to determine it because we have to determine through some rigorous maths whether the friction will be towards right or left. I keep on using that board marker.
If we're figuring out the people that are done, how are we supposed to figure out the friction?
That's what I'm saying. Na? Just consider a direction and proceed. And by the way, just to clarify further, if someone takes the friction to the right, he or she will get wrong answers. that's another bizarre thing.
Direction of friction isn't given, so how are we supposed to find out?
Take an intuitive direction, Hussein, and we have to proceed. But I can show you some manual or video that goes in detail how to determine the direction for different cases. Okay, what else? F multiply by?
0.7.
You mean the capital R, right? Okay, and then bracket closed, dt, okay, is equal to Ig delta omega. Ig, what is the value? Right, the radius of gyration is given. Again, very nice remark from Ahmed. Mass multiplied by kg, which is 0.35 square. One minute. June 6. Okay. Now I will write. Did I miss omega, by the way? I think I did. I think there is omega here as well. So I will write bracket omega 2 minus 0. That is omega 1. So last but not least, I will call this fellow as my equation. Come on, where is it? 1. Okay. Okay, do it. Finish the question. Is it clear? Okay, for those of you who just arrived, it's a point of concern for all of us. Why did I take the friction on the left hand side? I have explained this, that you just have to consider right or left. It's pretty ironic that it will make a difference between right and wrong answer, but we are not going to get into how to determine the exact direction of friction in a rolling problem. I know as a fact that in this problem it should be towards the left. I considered as left and I proceeded with the problem. So, doesn't matter, ne? Doesn't matter. Because F is an unknown. F in its own totality is an unknown. I have to figure out the F anyways. So we don't know. Nahin? Clear? Okay, let me answer his question in another way. Okay. I understand your question. Okay. I understand Ahmed's question. Good. So this is it a pure rotation problem? Is it a pure translation problem? Is it a general plane motion? General plane, na? So you wrote an equation of rotation. Now you can also write an equation of translation. So that will be your second equation. I understand your question. His question was that if friction is also unknown, then how can we figure out two unknowns from one equation? So I'm trying to answer his question. The equation of translation will be integral 0 to 5. What is impulse? You are Tehshin Chan, right? Chan? You are Mehmet. And who is Tehshin Chan? Right now he's not here. Mehmet Safa, Tehshin Chan. Okay, I confuse you with Tehshin Chan. So we have, what is impulse? Good, right? Impulse. So integral f dt is equal to change of momentum. Everyone, is it clear? You are following, right? That impulse is equal to integral f dt is equal to mv2 minus mv1 integral. What happened here? Integral m dt is equal to ig delta omega. So it's like translation and rotation. F equal to ma, moment equal to I alpha. Integral f dt is equal to change in translational momentum. Integral m dt will be equal to I multiplied by change in omega. So it is P minus F, as one of the students told me, and this is 0. Give me the answers, by the way. I have to finish the problem. Agreed, everyone? 2. 2 equations, 2 unknowns. Give me omega 2 and F.
Tan second is constant, right? In the P that was.
5 seconds. Then that 10 S is a second, 10 is a constant. Do you understand this question? You see that force is equal to T plus 10 S bracket capital N. Capital N is Newton. S is a second. 10 is 10. T is time. So force is variable.
For the integration total moment times dt, when we put in the values of total n. So PR, I understand that inverts through the page is positive. So
Clockwise is positive.
clockwise is positive. Why are we saying the friction is towards the left?
I actually, there are 2-3 students who asked me the same question and I answered the same thing again and again. The actual direction of friction, it's not easy to look at it intuitively and consider right or left. We have to go through rigorous mathematical steps. In this problem, I just knew that the F is towards the left and I went for it. If you consider the F towards right, you will have the wrong answer. So I just knew that it has to be left, I went for it. For a rolling problem, it is hard to determine, and there is some mathematical steps that are taught in which you can determine that whether F is towards right or left. In this case, we have to go for something and I went towards left and I solved the problem.
Yeah, if we do an assumption for the friction,
it can be wrong, yeah.
So we need to know the friction's direction.
Yeah, and if you don't know it, it is hard, but just consider a direction and
Well, we just guess, basically.
yeah, we had to.
If it's wrong, it's wrong.
It's wrong, but then that's fine because I am the one who has to look at the steps and I am focused more on the other steps than just the F. There are plenty of things that I'm worried about.
But we generally say that the friction is towards right in previous questions.
That's what I'm trying to tell you, that I keep using that board marker and I keep on rolling it. We don't know the situation. Somebody told us, I don't know how it is moving, how is it slipping. So it's hard for me to come up.
If the question say that there's no slipping condition, it will be right. If there's no slipping.
It is no slip condition. Who said that there is slipping? This is a no slip condition.
We don't know is it slipping or
No, this is a no slip problem. Who told me the slipping is happening? I think it's a no slip problem. No. Where did we say this is a no slip condition? But friction direction we don't know. So just consider the direction for this problem and proceed.
Do you know V2?
no, we're trying to find V2 values.
No, we're trying to find omega 2, but we have 3 unknowns and 2 equations.
No, 1 minute. I understand how the friction is towards left. Hang on. If there is no slipping, yeah, I got it. If there is no slippage here, then let's say if I write here, no slipping is happening. If there is no slipping that is happening, then just imagine it like this. If I have to pull this object, then there has to be friction in that direction for the object to just smoothly go. But if there was slipping that was happening, then I would have considered F towards right. Got it? So let's write no slippage is happening. He actually asked this question, and now, although I would still stick to my point that it's easy to consider it right or left and go for a wrong value. So that's why F at this point is not my biggest concern, but I want to answer his question. Let's say, what happened? Let me write no slip condition. Because you know what? In all the problems we have done so far, do you remember there was one problem with peeling out? The car was peeling out. It was skidding as it was going through. The peeling problem. The car was skidding, the tires, no. There were 3 students sitting in this class that day when I went for the lecture, so no worries. So peeling out, the car's tires were skidding. In that problem, I took the friction towards right. Then we had this problem in which there was a truck, there was a big barrel on the back side of it. I think in that problem, I considered the friction probably towards right. This is a no slip condition. So consider it like this. If I have an object, a big drum, and I want to roll it like this, and there is no slipping that is happening, how on earth it wants to roll? Probably because the friction is in that direction. So makes sense.
For sure.
Yeah.
So there is no slippage.
Yeah.
So for example, this system trying to turn like this, so there is no slippage. So when it's trying to turn and going with no slippage, friction is acting action reaction force, like this tires pushing like this. There's an action at the bottom side. So yeah, the friction I think will be in that direction.
Okay, consider it towards right then.
I have found friction as negative.
Really?
Which indicates.
Did you? No, it's not possible. It's in my notes. The problem. We got a positive F. Really?
Maybe I made a calculation. But like I found as a negative.
Oh, 1 minute. So, give me the value of omega 2, Ahmed.
I will tell you immediately.
Omega 2.
Our third equation will be
Just 2 equations.
what we feel on.
No, 2. We have omega and F. Omega 2 is 1.05 radians per second. And by the way, in this kind of kinetics diagram, I talked about the center of mass velocity. But if it is rotating, then it will also have a clockwise omega, let's say.
0.03 omega 2.
I have 1.05. Okay, I will double check with you. This is omega, and if you want to talk about alpha, I don't know, you can consider it as clockwise as well. Omega and alpha on the same object. Let's say alpha like this. So omega 2 is 1.05 in my notes. Let me just do it for you then if you are getting different answers than me. So let us go for integral PR plus FR. Now be with me and just tell me whether we are wrong or right. So we have P is equal to T plus 10 and we have 0.4 plus F times 0.75 bracket, then double dash dt, agreed? And is equal to, we have t square over 2 multiplied by 0.4 plus 10t multiplied by 0.4 minus 0.75 integral 0 to 5 f dt, correct, is equal to 100 times 0.35 square omega.
Why we said
Which one?
minus 0.75.
It's because I made a mistake. So it is plus. Okay, so now that I have this one, yeah, so this is my first equation. And instead of t, you will start substituting t equal to 5 seconds. And then last but not least, you will have the second equation that will give you integral p dt minus, so let's do it together, integral, because even in my notes I have changed the signs, by the way, minus integral 0 to 5 f dt is equal to, v is r omega, right? Did you substitute this instead of
Yes, I
v2?
did.
You did the
And I
capital
used
R.
The biggest R.
The bigger R. Good. So now from here, integral p dt. What on earth is this, by the way? I don't know. So what was p? P was did I give you p? T plus 10. So t plus 10 will be right. Then I have minus integral 0 to 5 f dt. Integral 0 to 5 f dt. You cannot open this, by the way. Okay, now take this to the left hand side. I think I have got your mistake, but it's possible that you did not make any mistake. What did you do here? Did you open this?
Yes.
No. Don't open this. I will tell you why. Acha, theek hai. I think I understood. Probably this is the mistake. Okay, instead of t, substitute 5 square over 2 minus 10 multiplied by 5. Correct? Now find the value of this big chunk only. Okay. Now give me the value of this and take this big chunk and substitute where? In the big chunk, because f, how can I say, how can you say that f is constant when the force is variable in its own self? We are just not sure what is the friction force, whether it's constant or whether it's varying. Sure. Okay, f will not come out to be negative. I'm pretty positive because I corrected this problem last semester. You have to tell me your name again. I'm so sorry. Mehmet Safa. Mehmet, are you clear on this one? Because there are two portions, rotation and translation. I wrote both the equations. I had two unknowns, friction force and omega. Then from here I got this integral FDT. I will put it there and I will crack the problem. And I will also answer Hussein's question. Can we do this with summation of moments? Just remember one thing, Hussein. This problem might be a little tricky for us to crack using summation of moments. I will tell you the answer. When you do summation of moments is equal to I alpha and summation of forces is equal to MA, again you will have two unknowns. You will have the alpha, that is the unknown, and the acceleration of the object as the unknown, right? Two equations, two unknowns. So exactly like this, we can solve it. The only problem is that the force in this problem is dependent on time. If force is dependent on time, you might get alpha that is variable. So even if you get alpha, you will not be able to use omega f is equal to omega I plus alpha t, because that equation only holds true for constant alpha. You will have to perform integration. You remember in the second week of the semester, I used to tell you that when you do not have acceleration as constant, you have to perform some integrations. So this problem might be a little tricky if you crack it using the summation of moment and summation of forces. Is this part clear, which I just explained to him? Although in principle, you can handle this problem with summation of moment and summation of forces. You ask me the question, please.
For V2, we said that R times omega 2.
Huh.
Right? So V2, which
Good.
V?
Very nice comment from Mehmet. By reminding me that I use V is equal to R omega 2, he also clarified one more thing in the problem. What he clarified? That there is no slip condition. Because the problem is many times I do not have the complete English statement written in front of me. I see the question that I have solved and I figure out the question. V is equal to R omega 2 can only be utilized by me in a no slip condition, right? Yes, I getting my point. When something is rolling, if there is no slippage at this point, then in your midterm 1, you remember you used to say V A equal to V naught plus R omega, and that V naught is 0. So this V is R omega. I have used that. That also means it's a no slip condition problem. And that's why I think I'm right by considering the friction towards the left. Good. Yes. Ahmed, Mehmet proposed a question.
So V2 is the velocity of the center, right?
Yeah.
Is that true? Okay.
Yeah, I can double check for you. I think so. Yeah, the capital R. Yeah, capital R is 0.75.
So V2 will be this velocity of center.
For sure. Look at the light blue arrow. Look at the omega and alpha directions. I think omega and alphas are in the same direction. So, by the way, in a kinetics, do we talk about acceleration and alphas, or we also talk about velocity and omega? I think we talk about acceleration and alpha. I don't think I ever told you to put omegas and v's. So I think today for some stupid reason I went one step further. Omega, alpha and A I used to put. Please bear with me. I just want to be a little meticulous. So sorry. Let us do another problem quickly. We have students who want me to do another problem today. Bear with me. Okay. This is the direction of A and alpha. Okay, now let's do another problem. Okay. So okay, instead of writing, can I just explain like this, or do you want me to write? I can write, by the way. Should I write? Okay, I can write, I think. I don't want to. Because sometimes when you keep on showing stuff, it becomes hard. So it is out of that. Yeah. Right. So let's talk about general motion. We have general motion. Okay. I have this big fellow that is moving. I have this is the nice and beautiful floor. And we have, what was the formula, if anyone can know? What is U12? O means outside, NC means non-conservative, equal to delta T plus delta VG plus delta VE. O stands for outside, NC stands for non-conservative. Work done by outside and non-conservative forces. This is my point, boom, A. I will call it as zero velocity, and I will use this as omega. This is the velocity pointed towards right. By the way, right now I'm really asking you, in the kinetics diagram, are we only using A and alpha, or I also used to indicate V and omega? Can anyone double check for me? In the kinetics diagram, I'm just curious today. If you can just answer, I would really appreciate it. Right? V and omega, I never used to do it. So I'm sorry, in the last slide, I somehow confused you. So this is R. This is zero velocity, which is known as no slip condition. Agreed? Okay. Now, friction is the work done by non-conservative and external forces. Okay, then why don't you all help me with this part? U12 will be equal to integral 1 to 2. Okay, so I'm talking about outside and non-conservative. So anyone who can help me, it will be integral F. This is rigid body kinetics, remember, plus integral 1 to 2 C dot d theta. Okay, so we will have what is C d theta? I have to talk about this. Now T is equal to translation plus rotation, which is equal to half mvg square plus half I g omega square. Why? Because I have just remember that it's a wheel, and today I will talk about no slip. I think it's clear already, so I'm not going to get into that. What is integral C d theta? I have to talk about this as well. Okay, I will talk about it.
You see the linear velocity?
No. C should be the applied moment, no? Right? If this is FDS, then it should be applied moment, M d theta. Yeah. So C is M, but I'm not sure why out of the blue I have started to use the C. But C can be the, yeah, you can use M for applied moment. Okay. Then if I have no slip condition, then can anyone tell me what will happen to this T? It will be
0.
No. If there is a no slip condition. So I will have, instead of V, I will have R omega. In no slip condition, I have V as R omega. So it will be plus 1 over 2 Ig omega square. So T will be equal to 1 over 2 omega square into mr square plus Ig, which is equal to, anyone who can guess? Oh, space is over. So T will be equal to half omega square into I subscript A. Not sure if anyone agrees with me, but
Yeah.
it makes sense, right? Okay. Acha, I need to explain this because we have students who are saying, what on earth is C? You did not explain this. Yeah, if I am taking FDS, then total kinetic energy, this will be M d theta. So I am using my hand to rotate this wheel, right? And at the same time, someone is also pulling this wheel. So integral FDS is the external force that I'm applying. So U equal to integral FDS. I'm sorry, integral FDS is the external work energy, and integral M d theta will be the applied moment work, I would say. So it's not M d theta. For some reason, I have used C d theta. Anyways, now please realize that if there had been some sort of friction or some sort of resistive force, there will be a negative here, and I will add those. I will subtract the friction work or whatever. So C is the M apparently in this problem. There is no other explanation, by the way. All those derivations, I hope I didn't confuse you. It's correct. Everything is fine. We have done this in a rigid body problem. I'm just saying in a general plane motion, I have rotation as well as translation. The U will have two components because of the force and distance because of the applied moment. When I have to talk about the total kinetic energy, come on, it will be translational plus rotational kinetic energy. This is not like a simple block that is sliding. It is rotating as well. There is translation as well as rotation. And then I can say that it is nothing more than omega square multiplied by IA. Okay, for those of you who are getting confused, I will just open a problem for you. Why don't you do this problem and tell me if everything is fine or not? Do this problem. Don't look at the solution, please. We have 10 minutes. Oh, come on. Let me open this for you. Hang on. Yep. Yes. Okay, so let me do some steps here.
Previous question is done.
That was not a question. That was just, I was telling you. This problem, done. I gave you the answer. Show me. Did you write the answer?
1.0.
Yeah. So you have two equations. You have one equation from here and one equation from here. Two equations, two unknowns. You will take the integral f dt, which is this chunk. You will put a negative sign to the right. Take the whole big chunk and put in this integral f dt, this big chunk. So you will have omega 2 that is scattered inside here. So now the complete equation will have omega 2, omega 2, omega 2, omega 2. You will get. Okay. And probably you will not be able to even. Probably you can find friction afterwards. Acha. So let's now make your life a little difficult. I will remove all these things. And okay, let's see if you can do it. Done. Okay, let me look at the problem. The question says a horizontal spring remains unstretched. At horizontal spring remains unstretched. Find the omega at horizontal. The K value and the M values are given. The theta 30 degree is given. The length of the rod is given. The question says that the mass of the rod is 10 kilograms, whereas the ends that has those little wheels, those are massless. I think so. Okay, do the problem. Gentlemen, the problem is clear, right? Ladies and gentlemen, probably. Okay, do the problem then.
So, while taking the integral of FDS, should we use the degree or the radian?
integral FDS? There is no applied force in this problem.
The spring force.
No, hang on. Are you talking about the U12 or are you talking about the delta VG? Look, U12 means non-conservative and external forces. In this problem, nobody has told me that there is any external force or there is any external moment for that matter or any friction that is present here. So U12 only constitutes the external force, the non-conservative force, the friction force, all of that part. Now you have delta T and VG, delta T and delta VG and probably delta VE that is left on the right hand side. Now ask me the question, please, again.
While calculating the spring force,
Ha.
the energy that is being used by the spring force, should I use radian or degree while taking the integral?
Acha, okay, got it. I will answer your question like this. I just need to double check one thing. Delta VE. Okay, I will answer your question because I'm myself a little thinking why radians are coming into the picture when I'm talking about the K values. Okay, let me just at least do one step and then probably it will be clear. Delta VE. Okay, let's do the delta T together first, then I will answer. T2 minus T1, correct? And then I have it is equal to half mVg square plus half. Okay, any other component of kinetic energy? Mirch, I said T2 minus T1. So it will be half. Half m, good. Okay, he already answered. So half I omega square. Any student who can explain why do we need I omega square in this problem? Because there is rotation, right? Okay, minus, what is the value of T1? It is 0. Because that is what the question said, I suppose. This is my state 1, this is my state 2. T2 should be 0. No, because the question says that I stretched it like this. There is a certain value. So the V1 is 0. I left it and and when it is passing through that horizontal, there might be some velocity. Now it is equal to, let us finish the question, half mVg square plus half Ig omega 2 square. It is equal to half Ia omega 2 square, which is equal to, now what is the moment of inertia of the rod about its center? That is ml square by 12. What is the moment of inertia of the rod about one of its ends? It is equal to 1 over 3, right? ml square omega 2 square. Not sure whether it is clear to all of our class. I did explain this before. So now I will have, it is equal to half, okay. Now, if you don't like this and you are saying it really confuses me what you just did, I want to follow the original expression, then I will help you with that one. Half m. What is Vg, by the way? It is equal to, Vg is equal to R omega. So R is L by 2 omega 2 square. And what is the value of Ig? It is about its center of mass, m L square over 12 omega 2 square. If you add this whole chunk, you will have the same answer as I showed you before. So you can do it yourself. M L square over 6. I don't know. ML square over 6 omega 2 square plus ML square over 24. Did I make a mistake? I think.
I think this should be 8.
Yes.
2 2s are 4, 4 2s are 8. Huh? I think so.
And then you multiply by 3 and then you divide everything by 4, it becomes 6.
Sure?
Yeah.
Nee, 1 minute. Say that again. So this will be 8.
And when you calculate them, it becomes 1/6 ml square, which is the same with the other expression.
Oh, okay. So okay. My point is, am I getting this one, green one or not? Yes. The answer is yes. Yes. Okay. As long as I'm getting the green expression. Okay. Ha, 4 6 are 24, 1/6. Good. Confused? Wait, this is a rod, right? The rod is going like this. So does rod itself move upward? For sure, the rod's center of mass moves upward. Is the rod rotating? Yeah, it is. So there are two forms of the energy, kinetic energy. One is the translational kinetic energy that is given by 1/2 mvg square, and the fact that the rod is rotating gives 1/2 I omega square. So I have to add both the components. But there are no masses at the end. Those are massless. Otherwise, the problem will become complicated. Now I will answer his question about the spring. Okay, you have to give me 3 more minutes, please. So now I will answer his question. What is delta T? It is 1/6 10 kg. Then we have 0.4 square omega 2 square, right? I think so. You can see 1/2 1/3 ml square omega 2 square, which is equal to, finish the question, 0.267 omega 2 square. Last but not least, I will have delta Vg and then I will answer his question. Delta Vg is equal to mg delta H. So mass is 10 kilograms. G is 9.81 meter per second square. What is delta H?
L times sinus 40.
L by 2.
No, not sinus 40.
Sine 30. Yeah. Sine 30. But L by 2, not L. Because at the end of the day, I'm talking about center of mass. How much center of mass moves. So that is L by 2 sine 30, not L sine 30. Very easy to make this mistake in exam. 0.4 divided by 2 sine 30. Because this is how much your center of mass moves. So you will get a final answer of 9.81 Newton meter. Agreed or not? Mirj, do you agree? Sine 30. Why divided by 2? Because look, the whole rod is 0.4 meter. How much the center of mass moves upward? It is this 0.2 meter, 0.2 sine 30. So this distance is 0.2 sine 30.
So it's not the height difference between the rows.
No, because center of mass acts at center. So how much potential energy is changing? I am concerned about the point the point where weight is acting. Now I will answer Ahmed's question. Delta VE is equal to half K. I was not sure where the radian came into the question. That's why I was saying I will arrive here and then I will answer. So it is equal to, what is delta 2? So the question says at horizontal, spring remains unstretched. That means the delta 2 will be 0. So I have half K 0 square minus delta 1 square, which is equal to minus half. K is 800 given to me, multiply by delta 1 is 0.2 square. And students who are saying, how did you write delta 1 is 0.2? Why did I say delta 1 is 0.2? Because anyone who can tell me why delta 1 is 0.2? Delta 1 is 0.2. Because
Hocam, the spring
Hmm.
will be
630 times 0.4 is equal to 0.2.
at 0.2.
Yes, last semester I asked exactly the same question. I still remember the name of the student who exactly answered the
Same way.
same way. Last semester I also stopped here. Why I'm taking 0.2? Okay, and I get minus 16 Newton meter as delta VE. Thank you for your patience. Finish the question. U12 O and C is equal to delta T. What is delta T? I think we found as 0.267 omega 2 square. What is delta VG? We found as positive 9.81. What is delta VE? We found as minus 16. So what is the value of this fellow? It is 0 because there is no external force or moment for that matter. Plus point. Now I will also add one more thing. How will I change this question in an exam? Please listen to this because I have to make exam for you. Omega 2 is equal to, comes out to be 4.81 radians per second. In an exam, how can I change the question? Let's say I can talk about an applied moment. So it's very intuitive to just follow what I did in class, but the students who will remember the concept will say, oh wow, U12 external non-conservative. Come on, if he is applying a applied moment, integral m d theta is not 0. I cannot put a U12 0. M is given to me. I will have to figure out integral m d theta. Then I have to proceed in the problem. You get my point?
We have to do integral f, yes.
Or integral m theta, depending on whether I am applying a moment or I am applying a force. Thank you. I exceeded 6 minutes today, by the way. The mean I extended the deadline.
Yeah,
I did.
Yeah.
Okay.
that sounds, yes. Thank you. See you, John.
See you. Bye bye. Thank you. I appreciate it. Bye bye. Let me